Welcome to Azure Mythbusters. And today's myth, Kubernetes is hard.
It's not that easy, but we're going to make it a lot easier. My name's Justin Davis.
And I'm April Edwards.
Containers are everywhere, and everyone's talking about Kubernetes. And I think when we talk to any customer or any development team, really they start thinking about the power that containers can give to them when they're actually developing their applications. A couple of industry analysts and surveys have come out really showing the propensity for people to be able to pick up containers and to be able to actually migrate their applications over. So Gartner says by 2020, more than 50% of enterprises will run mission-critical applications in containers. If you think about what they're actually doing now, most of that is in infrastructure as a service, or it's actually on-premise itself. And half of the container environment is being orchestrated as well. And that's really what we're going to be talking about and demoing as well, is Azure Kubernetes Service to be able to show a container and it running on the cloud.
So Justin, what is a container? I mean, and what's an orchestrator? So I've heard of Docker.
Yep.
I know it exists, but what is the orchestrator piece of it? Like, why do I need it? Can I just not containerize? What benefits does the orchestrator have?
Okay, so let's start with the container first of all. So when you write an application or an application which is running on your desktop, for example, an application depends on a number of things. You have the executable, but it may depend on 2 or 3 different libraries, and you may have to have some configuration in there as well. If you imagine you, as a developer, you're developing on your laptop, and you need to basically get that application and the configuration and its dependencies into production. I've worked at organizations where you would literally zip all that stuff up, put it into an FTP site, and then you'd write a run book for someone to basically go copy that, unzip it, and pray to God that it basically works.
And you're running it on your laptop versus in like your same environment you'd be running in production today.
So yeah, I mean one of the things that you hear from developers a lot is it works on my laptop.
Yep.
Why doesn't it work in production? And containers actually fixes that, because what you're doing with a container, much like a shipping container, is that whatever you put into the container is there on the other end. So
Awesome.
If I run the application, all the dependencies, all the configuration, although configuration you do it in a slightly different way, all within a container, if it runs on your laptop, you're guaranteed that it's going to run exactly the same way in production.
Awesome. That sounds really beneficial.
So we'll come on to what an orchestrator is in a second,
Cool.
okay? This second, funnily enough.
Awesome.
So we've got a single application like I just talked about now. The problem is that most complex applications, and anything which is kind of bigger than a very small application, probably is going to rely on another application, which is going to rely on another application. And when you're talking about the web, actually you're talking about a front end talking to an API, which may talk to another API. All of a sudden you maybe have 4 containers that you have to figure out what you need to do with.
Okay.
When you're talking about web scale, you may have hundreds of these containers to be able to deal with. And the way that you'd work with a single container is doing Docker run. Now, you don't want to do that 100 times, right?
No, because if I have 100 containers or multiple applications, multiple instances,
Yep.
what do I do?
You're essentially making the life of having to look after your infrastructure as a service, you're essentially moving that over to Docker containers, and you're not really getting the benefit of what you get out of containers.
Okay.
And so what an orchestrator does, it basically allows you to be able to say, container number 1, or let's call it my API function. Mm-hmm. API function, please go and run it. Now, with Kubernetes, it will essentially say, what servers do I have, what infrastructure do I have, and it will pick the best place to be able to run your API. And if that underlying server goes away, so if you have a hardware failure, Kubernetes will say, well, it's not running here anymore, so actually I'm going to go and run it on something that I do have available.
So if I have a failure in my application or even a hardware failure, so if I'm maintaining a massive environment and I lose a node out of my cluster, something happens, this will automatically replicate it to another cluster?
Yep, exactly. Well, not to another cluster, but to another node within the cluster itself.
Okay.
It has other benefits as well, though. If you start looking at the ability to be able to scale up and down, so to be able to respond to traffic, for example, I could say my API needs to go from 1 instance to 500 instances. Again, in the old school way, you'd have to think, well, what servers does that go on? I have to essentially repatch my load balancer, and it takes time. With Kubernetes, you basically say, please scale this pod, which is the container running within Kubernetes, 500 times, and Kubernetes takes care of the rest of it.
Yeah, so I'm an organization, and maybe we're seasonal. We know when to expect a spike.
Yep.
So we have to buy our hardware and buy our infrastructure to maintain this. And sometimes our website gets flooded, it goes down, and it can't handle that traffic. This sounds like this would absolutely handle it for us.
Yeah, it essentially abstracts the developer and the organization away from the infrastructure, when actually then you start thinking about the workloads, the important stuff that people want to deal with. So if we start thinking about really the Kubernetes landscape and what we have as a managed service, there's this thing that you call roll your own Kubernetes. You can go and get the individual components, you can install it onto infrastructure, and you can kind of tend to that as you want to. There are so many moving parts within Kubernetes that you kind of, unless you've kind of got a few weekends that you just want to burn, you really don't want to be doing that and dealing with that. You certainly don't want to be dealing with that in production.
So Justin, this sounds like it takes a lot of feeding and watering.
Yeah, so I mean, if you're going through and having to set up all of these different parts of the application, you don't really want to be doing that. And you certainly don't want to be doing that in production.
No, absolutely. So how do we resolve this? Like, what's our solution?
We have a managed service, AKS, Azure Kubernetes Service, and essentially you're asking Microsoft to essentially spin up these AKS instances or these Kubernetes instances for you. And we have images which basically are deployed into infrastructure, and we manage the control plane for you. The control plane is the part where actually you talk to Kubernetes to tell it to run a pod or to be able to scale something up. And all of that is totally backed by Microsoft, and we look after that for you. So one of the most difficult parts of actually running Kubernetes, if you're running it yourself, is how do I have a live system and in the background upgrade it to a new version of Kubernetes?
Right, exactly.
It's actually quite difficult, because you have to figure out how do I shut down one node, move all of the workloads off, then I have to do the upgrade. Is everything okay? Is there a health check? And then I move the workload back, and then so on and so forth all the way through.
Because I'm doing that in my on-premise environment today.
Yeah.
Every time I have to upgrade an application or something, I have to move a workload off a cluster or to a node somewhere else, evacuate, test it, and hope it works and comes back online.
Exactly.
Okay, so this is great. It sounds a little bit expensive.
No. So this is the good news, actually. So in terms of the control plane element, the part that you talk to, that's free. So
Wow.
we basically look after all that for you. We make sure that it scales for you as well. As your workloads increase, we essentially scale the control plane for you.
Cool.
The only thing that the customer pays for is the worker nodes, essentially. So if I have a cluster of 4 nodes, I just pay for those 4 nodes.
So the Kubernetes service is
It's
free.
free, exactly.
Wow, that's awesome.
Yeah.
That's really cool.
And also as well, it's available in pretty much all of our regions now as well, in terms of people being able to have that. So if you're a global organization and you're looking at Kubernetes, you're looking at deploying into containers, there really isn't another platform to be able to go to.
And that's a game changer. That's absolutely a game changer. That's awesome.
So let's look at kind of what AKS actually provides for you. And it really takes the idea of Kubernetes, but wraps the managed service around it. So as I said, deploy Kubernetes with ease, and we'll show that in a second. Scale and run your applications with confidence. This is critical, really. If you think about the fact that we have availability sets, the fact that we have availability zones,
right.
We support all of that within AKS as well. So the standard availability and resilience that you get from Azure infrastructure is baked into AKS. If we look at AKS and what we offer as a managed service, as we discussed, it's really easy to be able to spin up an AKS cluster, and we'll do that in a second. The whole idea that all the underlying infrastructure that we have underneath AKS is the same thing that you get from your infrastructure as a service on Azure. So the things like availability sets, availability zones, all of those are baked into AKS.
So all that resiliency is there.
All there.
Awesome.
Without you having to do anything. We basically do the striping for you across the infrastructure.
Oh, wow. That's awesome. That's really cool.
We've talked in the past about Azure Active Directory. One of the great things as well is that Microsoft is really good at enterprise, and when we have a service which comes online into Azure, we want to make sure that it's enterprise ready. So the ability to be able to integrate into Azure Active Directory, have role-based access, and have that federation of those user accounts into AKS is just there as well. It's a tick box, you just turn it on.
Wow, so that's enterprise ready, it's a managed service,
Yep.
It's resilient, and we can bring our identity and our authentication to that platform.
Yeah, absolutely.
Awesome, that's really cool.
And then moving on, if we then look about things like VS Code, GitHub, you talk about Azure DevOps as well. One of the main kind of drivers for Kubernetes adoption is that it actually makes developers' lives easier. It makes operations' lives easier. And the full integration in terms of all of those developer-led applications and tooling is there as well. So to be able to stitch kind of an end-to-end pipeline together, from my laptop through GitHub, into Azure DevOps, into AKS, it's just seamless.
Cool. So I can develop my code with like VS Code or Visual Studio, my preferred IDE editor. Cool. I can put that into my Git repo, and I can deploy that in things like Azure pipelines, and that's all baked in and all seamless.
Absolutely.
Really cool. That's really, really cool, because I want an end-to-end solution in my enterprise for my application delivery.
Yeah, you don't want to spend the next 6 months trying to figure out how to do this, right?
No, absolutely not.
One of the really interesting things, and I think quite important things for people to be able to realize as well, is that even though it's a managed service, we essentially take what is the open source part of Kubernetes from GitHub, and that is what you have as the service. We don't modify that, we don't add to it whatsoever. So if we need to have a feature within Kubernetes, we will actually commit that into the core of GitHub.
Okay.
When that gets accepted by the community, that is when it comes back into our service. So we have this feedback loop with us pushing into open source being put into the product itself. And customers can see what's on the roadmap just by seeing what we're doing on GitHub as well.
So it sounds like Microsoft is a massive contributor to this open source community.
We are, and we love it very much. Our development teams that work with it, both the upstream and the product teams as well, they're fanatical about it.
Awesome. That's really great. That's really great to see Microsoft evolving into such a big player in the game.
Yeah, absolutely. So we talked about the security aspect of it. Obviously, Azure Active Directory integration, but also things like VNet integration, so that actually your pods, as they're running within Kubernetes, actually look like they're part of your network. There are options for you to be able to do that. So if you think about the security model, your CISO is going to be happy because they don't really have to change anything for what you're actually doing in container applications. And we heard so much from customers when they're looking at containers, it's kind of like a black box. And that's like the worst thing for a CISO, right? Is that they basically want to know what's going on. We're just making it easier for the entire organization to be able to adopt this as well.
Yeah, and I think you touched on it. It's an enterprise-ready service, and you talk to your CISOs, your security teams. If they see a black box, they're scared because it could be anything, right? It's great to see that we have all these features built into it, all these security capabilities built into it as well.
Yeah, absolutely. And finally, obviously, loads of services on Azure are actually compliant with it with a number of local regulations as well. So that kind of flows through things like HIPAA, things like SOC, all is there and baked into AKS as a platform. So, you really can just say what services are there, what services fall underneath these regulations, and away you go.
Wow, that seems really, really easy.
Yep. Just before we go to the demo, kind of the last thing as well, kind of the secret sauce that we bring to AKS and container-based workloads. We've worked really hard to make sure the ecosystem is there, purely from a container perspective. We have built-in auto-scaling, so you were talking about earlier on, I know that I'm going to get peaks and troughs of my traffic. You can turn on the ability to be able to scale the underlying infrastructure out when I need more infrastructure based on the workload, and then be able to scale that back in automatically based on certain thresholds.
That sounds absolutely helpful in my organization as well, because I don't have to buy this massive compute power in the cloud. I can buy what I need to run 24/7 and be ready to scale.
Absolutely.
That sounds perfect.
And nobody gets paged at 2 o'clock in the morning when there's been a spike, right?
That's even better.
Yeah, exactly. Obviously, 53 regions that we have globally as well to be able to have that reached. The ability as well, we have this idea of a serverless container. So this is called ACI, Azure Container Instances.
Okay.
I can basically say to Azure, please run a container for me, and it will go, and you don't have to worry about the underlying infrastructure. That's actually fully baked into AKS as well. So instead of having virtual machines backing this, I can say for peaky type workloads or ETL type workloads, it'll just go spin that up for me, and it'll kill it once that job's finished. So these types of nice innovation that we have are there and baked into the product. And then finally, one of the really cool things that we have is the Azure Container Registry, so the ability to be able to store my containers. Obviously, you have the public Docker hub, but you can actually have your private one as well, which is totally within your network. A really cool feature of this is the ability to be able to check a Docker container in, and that can actually be geo-replicated to other data centers globally.
Wow. So I can have my own image in my own organization. I don't have to put up a Docker hub, and I can replicate it across the different Azure data centers.
Exactly. So especially if you're having a globally distributed Kubernetes instances, let's say we have one in Singapore, let's say that we have one in the UK and one in New York, my dev team in the UK can check that Docker image in, and that'll get automatically replicated to the 2 other sites, so that when we're pulling those images down, it's really, really quick.
Wow, that sounds fantastic. Let's see your demo.
Okay. Right, so I'm here in my terminal, and I'm going to use the AZ command line just to spin up a very quick AKS cluster to show how easy it is.
Okay, great.
So first thing we need to do is create a resource group, AZ group create, the name of the group, AKS demo, and the location, let's put it in East US.
Sounds like a good location.
Yep, it's my favorite.
Good.
Okay, so we need AZ AKS create. I'll give it a name, AKS demo 1. I'm going to put it into the AKS demo group I just created. And I'm just going to spin it up with a one node cluster at the moment. So what's going to happen now, as we talked about earlier on, we have the control plane element, and we also have the virtual machines, which are my worker nodes. Azure is going away and essentially carving out a control plane for me, and is spinning up that one node.
Okay, great.
Right, so now that we've got a cluster ready, I'm going to take a load of code, the API that I talked about earlier on. I'm going to compile it into a Docker container. And then what I'm going to be able to do is to be able to deploy that into Kubernetes to show how easy it is.
Okay, so we're taking some code, we're containerizing it,
Yep.
and then shipping off to Kubernetes.
Yep, exactly. Cool. So this is kind of like a wider application that we're running. There's a couple of containers which I've already deployed onto this that kind of builds this together, a load of microservices. We're literally just going to show how easy it is to be able to push this in. Bearing in mind, all we've done is AZ AKS create. We have the infrastructure there, and we're just using the standard kubectl command to be able to interact with that cluster.
Okay.
Let's go ahead and have a look at Visual Studio. So here's my API, just a simple Docker file. Because Visual Studio Code is built for developers, it just makes lives a lot easier. If I go to a Docker images build and go for the API, and essentially now Visual Studio Code is calling Docker, doing the build for me within here, and when it returns, we're going to do a push, and then basically we're just going to deploy that as a YAML file into the cluster.
So when you're building this Docker container from VS Code, walk me through it. Like, what's it? So how does it package everything?
So we have the Docker extension within Visual Studio Code. So obviously Visual Studio Code is very extensible, and there's lots of different extensions that you can have there. The Docker extension literally allows me to be able to do a shortcode, so Shift, Command, and P on a Mac. And if I just do build, then it allows me to be able to, it scans through everything I have in my local source code for a Docker file.
Okay.
So if I do build image, like you just asked, you can see that it has a list here of all of the Docker files for all of the code that I have. So I can just choose any one of them, and it will literally do a Docker build on that for me, and then I'm good to go.
Awesome.
The alternative is that I just go to a terminal and do all of this, but the fact that I can just use keyboard shortcuts just makes life.
Absolutely, and it's all built in VS Code, it's pretty seamless, and it all syncs across to Azure.
Exactly.
That seems like a really, really good solution.
So now that we've built our Docker container, we're just going to push this up to, in this case, Docker Hub, Docker push.
And again, this is the public repo of the Docker.
Exactly,
okay.
so that would mean that anyone can basically download this Docker image that I have.
Okay, but what about your code?
Well, so this is based on Python, so if somebody downloaded that Docker image, they would be able to look at the code inside there as well.
Okay.
And this is why it's critical, especially when you talk about containers, that you don't put sensitive information in them, because people can look inside there and actually see what's going on. So database credentials, for example, is a big no-no.
Yep.
And actually, I can show you in a second how you actually get around that within Kubernetes as well.
Yeah, and that would be great, because we have a lot of customers that are using GitHub as their source repo, and I think the same goes for that. If you have a public repo, don't put code you don't want shared, don't put in credentials, et cetera.
Absolutely, yeah. So, and actually talking about that, so one of the things that we have in things like Azure DevOps is the ability to be able to have secret variables, right? And those secret variables could be used to be able to store that type of information. So your security team or your data team, for example, can look after those credentials. And essentially what you're doing during the build time is to be able to actually inject that as part of the build into the configuration.
And your developers don't even have to know what the passwords are.
Exactly.
It's abstracted from them.
They just need to know what environment variable to be able to look at.
Cool, very cool.
Okay, so we have the image up there now. Let's go and look at the YAML file. And if you're dealing with Kubernetes, you just have to start to love YAML. It's all about indentation, but it's useful. It essentially allows me to be able to define what I want to do with that Docker container now. So the Docker container, I've just pushed it up to API DB, and essentially now what I want to do is to be able to run that.
Okay.
So again, I can have the Kubernetes extension in VS Code. So let's just go ahead and push that. Kubernetes apply. That's essentially going to apply this YAML file into my system now. Pushes that up. As you can see, appdb is configured. If we look over to our cluster, kubectl, get pods, and we have our DB, which is up in there running.
Oh, very cool.
It's that simple. I mean, once you actually have your Kubernetes cluster up and running, you interact with it just as you would do with any other Kubernetes cluster. Like I said, it's all based on the open source side of Kubernetes. There's nothing that we change to it. All of your tooling will work, all of your integration will work. We try and make it as simple as possible. I mean, when you're talking about containerizing applications, figuring out your CI/CD pipeline, those are other things that you just have to consider when you're adopting Kubernetes to be able to actually get the best benefit out of it. Right. But we are literally trying to make it as simple as possible for customers to be able to utilize.
Very cool. It seems like a really simple process to put your code first into an environment that's really scalable and has a managed service around it.
Yeah, absolutely. Just taking away the pain for our customers, right?
That's awesome. That's what every customer wants to hear. Thank you, Justin, for coming here today and telling us all about AKS and Azure. It seems like it's a seamless end-to-end deployment from your desktop using VS Code into the AKS service. I think we busted that myth. Kubernetes is absolutely easy to embrace in the cloud.
I'm a big fan of Kubernetes, as you know, so the ability to be able to deploy this really, really quickly, I think just makes our customers' lives much, much easier.
Thank you for tuning in today to Azure Mythbusters. We busted that myth. We're going to include some links for you for some further learnings on AKS and Azure.